Cette conférence va maintenant être enregistrée.
But welcome to everyone. I think that the reason why there are not so many people is because this topic of decontamination through autoclaving was already treated during the workshop on waste management that were provided next year. So it's not a surprise that there are less people. I just hope that you will find here a good summary of that. That was what was discussed during that workshop. So in this session, at first we'll look at the principle of autoclave and autoclaving, and also present the different types of autoclaves. Then we'll focus on the use of autoclaves or the decontamination, and that's in a COVID-19 context. And finally, I will spend some time explaining about the best practices with respect to validation of the decontamination process using an autoclave. The reason for that last part is that an observation that was made many times in Pakistan is that there is some control of the autoclaving process, but no true validation, and that's certainly something that can be improved. So the principles of autoclave and autoclaving. Autoclaving is a sterilization or decontamination process that uses saturated and pressurized vapor, water vapor, so it's steam, for biological inactivation. So autoclave, a synonym of that is steam sterilizer. Actually, an autoclave functions as a closed vessel to hold the pressurized steam inside of the chamber at the required temperature. And so there is a direct link between temperature and the pressure. In some types of autoclaves, the autoclave itself is also used to generate the steam, but it's only on some models. The most usual sterilization standard, and that's recommended by WHO, is 121 degrees during 15 minutes. So WHO also says that autoclaving is the most efficient and safest way to sterilize laboratory materials. So compared to other sterilization means like chemical means, for instance, last time we spoke about disinfectant, autoclaving allows a standard and reproducible treatment. So you will always work the same way. It's physical. And so you're not relying, for instance, on concentration or shorter contact time with a disinfectant. Also, it's there is a documentation of the validation to an autoclave. On most autoclaves, you have clear indication of that the cycle worked, for instance. You also have control and monitoring of the treatment cycle on some autoclaves, and I will say a little bit more about that. So in general, and that's everywhere in the world, there is a good acceptance by the authorities. Authorities then kind of trust autoclaving. If we look at the inactivation principles of autoclaving, actually the main inactivation principle, so the main factor that provokes the killing of microbiological agents, is the contact with steam. And the pressure is there to reach the right temperature and also to facilitate the steam penetration. The heat itself is a secondary principle, but the main factor is clearly steam contact. The best indication of that is if we compare autoclaving, which is a moist treatment, with dry heat. With most heat, so autoclaving, you need 121 degrees during 15 minutes, for instance, to reach some result. And that's equivalent 134 degrees for 3 minutes. If you want to reach the same level of killing or inactivation with dry heat, for instance, using an oven, you will need 160 degrees and for 2 or 3 hours. Or if you reach a higher temperature, like 200 degrees, you will need 1 or 2 hours. So you see that it's less efficient. You need more heat, a higher temperature, but also a longer time. So now the 3 types of autoclaves. The first one is pressure cooker type of autoclave. It's the simplest type of autoclave. The design is rather basic, especially on the model on the left-hand side, and construction also. It's quite simple equipment. On the other example, you see that it's a little bit more sophisticated with respect to controls, but basically it's the same functioning. The main characteristics of those autoclaves is that you need to put the water inside of the chamber together with the load, and then you heat, and the water evaporates and create the steam. The main limitations of this type of autoclave, there are a number of limitations. The main one is that there is no evacuation of the air from the chamber. Since when you close the chamber together with the load and the water, then even if you create steam, you don't evacuate the air. And because of that, you have a mixture of air and steam. And there is no good mixing of the steam with the air. That means that inside your waste bag, for instance, you are very likely to have air pockets. And in that case, you will not have the contact between the steam and the biological agents that you want to kill. So clearly, that kind of pressure cooker has limited efficacy for complex loads like waste bags, for instance. So pressure cooker type of autoclave should only be used to sterilize simple loads like instruments like glassware, media, and so on. But we consider that they are generally not suitable for highly pathogenic organisms because also there is no vent filtration, for instance, so it's not as safe as another one. And also not suitable for the treatment of complex loads, at least if it's the final treatment. The only way you could use them is that you can demonstrate that it works, and that means validation. So if it cannot be used for the treatment of complex waste loads and that you cannot demonstrate that it's fully efficient, that means that you need to take additional safety precaution for the packaging, for the handling of those wastes and so on after treatment. So from that point of view, it's better to use other means than autoclaving, like incineration, for instance. So in summary, pressure cooker autoclaves are normally not suitable for highly pathogenic organisms and for the final treatment of complex loads. If it's used for waste loads, in that case, you still need to take precaution with the waste loads and finally destroy them. The second type of autoclave is what we call gravity displacement autoclave. In that case, you don't need to put water in the chamber. You load the chamber, you put the loads inside of the chamber, you close the chamber, and then you see on the graph, the yellow arrows, you inject steam from outside inside of the chamber. In doing that, all the valves are closed except the one at the bottom. That means that the steam that you inject into the chamber will push the air down to that drain system here, and that is filtrated because you could generate some aerosols in doing that, and then it goes into the effluents. Okay, when this is finished, when you have put enough steam there, you close that valve, and from that point, since everything is closed, you will increase the pressure and also increase the temperature. So the main characteristic of this type of autoclave is that you push the air outside of the chamber, and in doing that, you have a much better distribution of the steam inside of the chamber. So it should be much more efficient. So the advantages of this type of autoclave is a higher efficacy, including on relatively complex loads. So it works well for waste bags, for instance. Also, most of those autoclaves have the possibility to work at a higher temperature, and the benefit of that is either to reduce the treatment time, or possibly, if results of the validation are not good, to also improve that efficacy. There is still one major limitation, is that you can still have some air pockets inside of complex loads. Indeed, if you have a waste bag that is closed or more or less closed, for instance, in that case, pushing the steam inside of the chamber will not necessarily push all the air outside of the bag. And so you can still have some air pockets. Still, this type of autoclave is the one that is generally recommended for not only for sterilization, that's always possible, but also for the decontamination of most types of infectious waste. And despite the limitation, this works most of the time. And to be sure that it works properly, then you need some validation. And that's why I will finish by explaining you that. So gravity displacement autoclaves are recommended for the decontamination of most relatively complex waste loads. So in most situations, except for perhaps for very high risk situation, this is the recommended type of autoclave for waste. The third type of autoclave is pre-vacuum autoclave. In this case, please look at the graphs. On the first graph, on the blue one, you see the principle with the former type of autoclaves, with the gravity displacement autoclave. When you have pushed all the air outside of the most of the air outside of the chamber, you close even the last valve, and in that case, the pressure increases. You reach the right pressure, and then you maintain it. You have also the right temperature, and then you cool down to discharge, to unload the autoclave. Okay, that's normal with autoclave. With the pre-vacuum autoclave, you inject some steam, and then you have a vacuum pump that takes the steam out of the autoclave. What's going on here? That takes the air out of the autoclave. Then you put more pressure, more steam, and then you pump the air out. And in doing that a number of times, in that case, you really empty the air pockets because you increase the pressure, and then you really suck the air out of it. And so in that case, we expect it to be much more efficient because this would reduce the risk of having any air pockets even in the waste bag normally. So the main characteristic, it's quite a complex equipment, and it must be equipped not only with a steam supply, but also with a vacuum pump. Other advantage of that, since they are made for kind of very demanding treatment, they also have many more cycles to be able to treat very different things. So the main advantage of this type of autoclave is a high efficacy, because you have an excellent steam penetration and then a good steam contact, including for complex loads. Also, it's possible to work at higher temperature, like for instance 134 or 35 degrees, which can result in shorter cycles. The main limitation is mostly on the economical side. It's more expensive and more complex at installation, but also for maintenance. So this type of autoclave is particularly recommended for the decontamination of complex waste loads in high-risk settings. So this is the type of autoclaves that, at least in the West, we'll use most of the time in BSL-3 labs. So it's time for the summary in Urdu. If Afsa could do it, please.
Yes, sure. Can you please make me the presenter?
Do I do it myself? Yeah. Mashal, could you do it, please?
You are the presenter, Dr. Hafsa.
Okay, right now I am. Thank you. Okay. Assalamu alaikum. I am Dr. Decontamination. Right. I hope everybody can hear me and see my screen.
Yes, Afsa, can go.
Okay, thank you. तो ये सेशन है बेसिकली ऑटोक्लेव के मुतालिक और ऑटोक्लेव्स और ऑटोक्लेविंग का प्रिंसिपल क्या होता है और ये किस तरह से काम करते हैं और ये इंस्ट्रूमेंट है क्या, इसके बारे में आपके ये थोड़ा सा इंट्रोडक्शन बताया गया। ऑटोक्लेविंग बेसिकली भाप के जरिए जरासीम को मारने का एक तरीका है और ऑटोक्लेव एक बंद बर्तन यानी क्लोज्ड वेसल होता है जो कि प्रेशराइज स्टीम यानी भाप को एक खास दर्जा हरारत पर कायम रखकर जरासीम को मारने के लिए इस्तेमाल होता है। अमूमन ये टेम्परेचर जो इसको दिया जाता है वो 15 मिनट के लिए 121 डिग्री सेंटीग्रेड टेम्परेचर होता है, जिसमें बहुत तरह के जरासीम को मारा जा सकता है। और ऑटोक्लेव को स्टेरिलाइजेशन का सबसे महफूज और मौसर तरीका समझा जाता है, और क्योंकि इसमें मुख्तलिफ किस्म के कंट्रोल्स और चेक्स होते हैं जो कि आपको ये मेक श्योर करते हैं कि स्टेरिलाइजेशन या डिकंटामिनेशन प्रॉपर तरीके से हो रही है। ऑटोक्लेव का प्रिंसिपल है बेसिकली भाप यानी स्टीम के साथ कांटेक्ट, जो कि हाई प्रेशर और हाई टेम्परेचर की मौजूदगी में अच्छे तरीके से लोड के अंदर जज्ब हो जाती है। लोड यानी वो कोई भी वो चीज़ जिसको आप ऑटोक्लेव के जरिए स्टेरिलाइज करना चाह रहे हैं या डिकंटामिनेट करना चाह रहे हैं। ड्राई हीट यानी खुश्क और हाई टेम्परेचर की निस्बत ये मॉइस्ट हीट यानी भाप ज़्यादा इफेक्टिव होती है। ये एक इंटरनेशनली नोन प्रिंसिपल है। सो ऑटोक्लेव की 3 टाइप्स हैं बेसिकली। एक है प्रेशर कुकर टाइप ऑटोक्लेव, एक दूसरा है ग्रेविटी डिस्प्लेसमेंट ऑटोक्लेव और तीसरा है प्री वैक्यूम ऑटोक्लेव। सबसे पहले हम लोग डिस्कस करेंगे प्रेशर कुकर टाइप ऑटोक्लेव के बारे में। इसकी साख्त, इसके कंस्ट्रक्शन डिज़ाइन बहुत ही बेसिक सा होता है, जो कि घर के आम प्रेशर कुकर की तरह होता है, और इसके अंदर लोड के साथ थोड़ा सा पानी डाला जाता है जो कि गर्म हीटअप होने के बाद भाप प्रोड्यूस करता है, और वो भाप वो स्टीम जो है डिकंटामिनेशन में हेल्प करती है। इसकी मेन लिमिटेशन है कि इसमें पहले से जो इसके अंदर, इसके चैम्बर के अंदर, वेसल के अंदर जो एयर मौजूद होती है उसको निकालने का कोई तरीका नहीं है। इसकी वजह से एयर पॉकेट्स बन जाते हैं और इन एयर पॉकेट्स के अंदर स्टीम दाखिल नहीं हो सकती, जिसकी वजह से मिक्स्ड और कॉम्प्लेक्स किस्म के लोड्स को हम लोग 100% तक स्टेरिलाइज नहीं कर सकते। इसके लिए कॉम्प्लेक्स लोड डेफिनेटली मुश्किल हो जाते हैं। तो इस वजह से इसके लिए सिर्फ सादी चीज़ों मसलन कैंची, औजार, मेटल, शीशे, धातु वगैरह की चीज़ों को स्टेरिलाइज करने के लिए इस्तेमाल होता है, जबकि ज़्यादा मौलिक जरासीम से आलूदा चीज़ों को ये मुनासिब तरीके से मुनासिब लेवल तक प्रेशर कुकर टाइप ऑटोक्लेव इसको स्टेरिलाइज नहीं कर सकते और आपको फाइनल ट्रीटमेंट की ज़रूरत होती है। दूसरी जो टाइप है प्रेशर कुकर की वो ग्रेविटी डिस्प्लेसमेंट ऑटोक्लेव है। इस तरह के ऑटोक्लेव में चैम्बर के बाहर से स्टीम को चैम्बर के अंदर इंजेक्ट किया जाता है, और भाप क्योंकि आम हवा से हल्की होती है इसकी वजह से वो ऊपर को उठती है, और हवा क्योंकि स्टीम की निस्बत हल्की होती है इसलिए वो भारी होती है। इस वजह से वो ग्रेविटी के इफेक्ट के अंडर आकर वो नीचे की तरफ को ट्रैवल करती है, और इस तरह ग्रेविटी के असूलों के मुताबिक चैम्बर से खारिज हो जाती है बजरिया फिल्टर ड्रेन्स जिसके साथ कनेक्टेड होता है। मेन कैरेक्टरिस्टिक इसकी इस तरह से ये है कि जो इसकी मेजर लिमिटेशन है वो ये कि कुछ ना कुछ हवा चैम्बर के अंदर फिर भी रह जाती है, जिसके इस चांसेस की वजह से कॉम्प्लेक्स लोड को हम लोग पूरे तरीके से नहीं इसको ऑटोक्लेव कर सकते। इसके बावजूद ये तरीका खासा मौसर है और हर किस्म के आलात और कम कॉम्प्लेक्स लोड को स्टेरिलाइज करने के लिए ये रिकमेंडेड तरीका है। जो तीसरी टाइप है वो है प्री वैक्यूम ऑटोक्लेव्स। इस तरीके में हवा को मुकम्मल तौर पर चैम्बर से निकाल दिया जाता है और खला यानी वैक्यूम क्रिएट कर दिया जाता है और हाई प्रेशर दिया जाता है, और इसके बाद नेगेटिव प्रेशर के थ्रू स्टीम को इसके अंदर दाखिल किया जाता है। और इस तरह से जो हवा क्योंकि इसके अंदर बिल्कुल मौजूद नहीं होती, वैक्यूम होते हैं, इसलिए जो स्टीम अंदर दाखिल होती है वो पूरे तरीके से लोड के अंदर पेनिट्रेट करती है और जरासीम को किल कर देती है। और इसमें बहुत सी तरह के कंट्रोल्स भी हैं, जिसमें स्टीम सप्लाई के अलावा वैक्यूम पंप्स भी होते हैं और सेफ्टी वॉल्व्स भी होते हैं। और इसके फ़वायद ये हैं कि हर किस्म के लोड के लिए इसे हम लोग इस्तेमाल कर सकते हैं, और हाई टेम्परेचर तकरीबन 135 डिग्री तक का ट्रीटमेंट हम लोग अपने लोड को दे सकते हैं इस प्री वैक्यूम टाइप ऑटोक्लेव्स को यूज़ करते हुए। लेकिन इसकी कॉस्ट बहुत ज़्यादा है और इसकी इंस्टॉलेशन और मेंटेनेंस कॉस्ट भी बहुत ज़्यादा महंगी है। Over to you, Philip.
Yes, thank you. I see that there is no question for the moment, so don't forget that if you have any questions about this presentation, don't hesitate to address them through the chat box. Okay. So the second part is on the use of autoclaves for decontamination, and especially with respect to COVID-19. So we need to remember that the main inactivation principle with an autoclave is the contact with steam. So if you look at the two pictures, the first picture, you see simple objects there, like surgical tools and so on. In that case, you can put that in an autoclave. The contact with the steam will be good. You have a contact everywhere, and that's why we also use some baskets with and so on, so that the steam can go everywhere. If you look at the second picture, you have a waste bag that is more or less closed. The contact with steam is much more difficult. It's difficult for the steam to reach the inside of the bag. And also, of course, it depends on the type of autoclave, but basically it's more difficult for the steam to reach the inside and to have a contact with all the microorganisms that could be there. So clearly in the second case, the contact with steam, it's much more difficult. So it's much more difficult inside of a waste bag, especially if it's a big waste bag with many items, that on very simple instrument. For this reason, we need to remember that waste decontamination is more difficult to achieve than instrument sterilization. It seems to be a little bit strange, but that's the reality. So if we think about the efficacy of waste decontamination, there are a number of factors on which the efficacy depends. First, the parameters that are used for the treatment. It's mainly the temperature and duration of treatment. Normally 121 degrees for 15 minutes, but you could increase either the temperature or the time or both. Then the type of autoclave, the most efficacious is the last type that was presented, pre-vacuum type. Intermediate is gravity displacement, and that's the most recommended for most biological labs, I would say, at least for the treatment of waste. And then the less efficacious is the basic pressure type, pressure cooker type. Besides the type of the parameters and the type of autoclave, also important is the nature and the size of the bags or containers that you use. The most efficacious is real autoclave bags that allow the steam penetration. Smaller bags are also more efficient than large bags, for instance. So less efficacious are bags or containers that are not permeable to steam, so that steam cannot penetrate, and of course larger bags. This is something that is not so well known, and so I want to really insist on this particularity. There are many bags that are sold for autoclaving, and actually some allow steam penetration and some others don't. So all those bags are not equally good for autoclaving. The real autoclave bags are the ones that are resistant, but that allow steam penetration when they are heated. So above 100 degrees, for instance, the steam can penetrate the bag, even if they are closed. They are significantly more expensive than the other bags. But there are also bags that are sold for autoclaving, but they are not really autoclave bags. They are autoclavable, meaning that they resist high temperature, so they won't be destroyed by the high temperature, but they do not allow the steam in. And so those bags can resist even up to 140 degrees, but they don't allow the steam to penetrate. I would not be surprised that many of you, if you autoclave your waste, for instance, you use the second type of bags because they are less expensive. And if you are not aware of that difference, we will not look for the other ones. Even if the bags are not optimal, there are some tricks to improve the efficacy of treatment, even with the simple autoclavable bags. One possibility is to leave the bags open during the treatment, but that implies that there is a possible risk when handling, and even if you when you transport the waste bags in the corridors and so on. But and even if you open it at the last time when you load the autoclave, in that case there is still some possibility to be exposed, for instance. So it's one of the possible solutions. Some other people, they add some water inside of the waste bag before closing it, and that can be done if the bags are watertight, because otherwise you will spill some liquids on the floor when transporting. But still, in that case, you will create, when heating the bag, you will create some steam inside of the bag, but still you will not evacuate the air, so you might still have some air pockets. The third trick is to close the bag with a kind of rubber band that loosens itself when heated. So above 100 degrees, for instance, the rubber will kind of loosens itself, and in that case, there will be some steam penetration through that opening. So if you remember the previous session, we know that SARS coronavirus 2 is a very sensitive virus, including to heat. And for instance, it has been demonstrated that SARS coronavirus 2 is inactivated at 70 degrees for 5 minutes. So even if you use an autoclave with a cycle of 121 degrees during 15 minutes, we are well above that, that temperature that inactivates SARS coronavirus. So it should be suitable for most applications. If you treat waste with some coronavirus inside and so on at 100 degrees during 15 minutes, it should be enough to inactivate the coronavirus inside. You might still need to be careful if, for instance, you use a very high concentration of the virus. If you did some viral culture, for instance, in that case, to kill the whole population, it might not be enough. But it's impossible to tell that without checking it, and checking it is validation, and that's why I insist a lot on this. Still, even if we are for most application, the normal autoclaving parameters should be enough. Still, it's still recommend to improve autoclaving process, just because you also have other microorganisms that also need to be inactivated. So I would not say that the most important point is to inactivate SARS coronavirus. So that should be done, but you have more resistant organisms, and so it's your interest in some way if you have those other organisms to improve the decontamination process using autoclaves. Different steps or ways to improve waste autoclaving treatment in your facility. The first thing to do, I think, if you don't know it already, when you go back to your facility, is to identify correctly the type of autoclave that is available and that you are using there. For that, you can either look at the technical documentation of the autoclave. If you don't have it, you can ask for some technician. And for instance, you should know if you need to add water at the start or if there is something injected. And you should also be able, or at least technical person should be able to tell you if there is also a vacuum pump, for instance. A second way to improve the treatment is to improve the packing of the waste. And so, for instance, to invest in real autoclave bags instead of those bags that just resist temperature, or implement some measures to allow better steam contact. The 3 tips that I gave you before, for instance. And then the last step, and that's something where you can be sure that you are doing things correctly, is in validating the inactivation process. And that will be next chapter. So now it's time for a summary in audio. Ashal? Yips.
Hafsa, would you like to start?
Yes. Can everybody see my screen?
Yes.
Right, great. Okay. So COVID-19 के तनाजुर में अब हम लोग देखेंगे कि decontamination autoclave के जरिए किस तरीके से की जाती है, क्योंकि वेस्ट बैग्स के अंदर स्टीम दाखिल होना एक जरा मुश्किल होता है, इसलिए वेस्ट डिकंटामिनेशन एक मुश्किल प्रोसेस है। और एज कम्पेयर टू स्टेरिलाइजेशन, जो कि डिफरेंट इंस्ट्रूमेंट्स को, डिफरेंट सर्जिकल डिवाइसेस वगैरह को यूज स्टेरिलाइज करना आसान है एज कम्पेयर टू वेस्ट को डिकंटामिनेट करने के। वेस्ट डिकंटामिनेशन कितनी मौसर है, ये डिपेंड करता है कि आपने टेम्परेचर कितना लिया है, प्रेशर कितना रखा है, कौन सी किस्म का आपने ऑटोक्लेव इस्तेमाल किया है, और यानी अगर फॉर एग्जांपल आपने प्री वैक्यूम टाइप किया है तो वो सबसे ज़्यादा एफिकेशियस है, और अगर आपने बेसिक प्रेशर कुकर टाइप ऑटोक्लेव यूज़ किया तो उसकी एफिकेसी सबसे कम होगी। और ये कि आपने किस किस्म का वेस्ट बैग इस्तेमाल किया, क्या वो रियल ऑटोक्लेवेबल बैग है या फिर सिर्फ वो बैग है जिसको ऑटोक्लेव किया जा सकता है। अब इन दोनों बैग्स में डिफरेंस है। रियल ऑटोक्लेव बैग्स वो होते हैं जो कि जब उनको हीट किया जाए तो वो स्टीम की पेनिट्रेशन होने देते हैं, जबकि वो बैग जो कि ऑटोक्लेवेबल बैग है वो होते हैं जो कि पिघलते नहीं है और लेकिन स्टीम को अपने अंदर दाखिल नहीं होने देते। ये रियल ऑटोक्लेव बैग्स जो हैं वो थोड़े से एक्सपेंसिव होते हैं, ज़रा महंगे होते हैं, और जो सिंपल बैग जो कि ऑटोक्लेवेबल होते हैं वो इतने ज़्यादा महंगे नहीं होते, लेकिन वो इतने ज़्यादा उसकी एफिकेसी भी नहीं होती। तो अगर आपने ये वाले बैग्स यूज़ करने जो सिर्फ ऑटोक्लेवेबल है लेकिन रियल ऑटोक्लेव बैग्स नहीं है, इस सूरत में अगर आपने बैग को अगर थोड़ा सा खुला छोड़ देंगे अगर एहतियात के साथ उसे हैंडल करने के साथ, तो फिर आप इसकी एफिकेसी थोड़ी सी बढ़ा सकते हैं। इसके अलावा आप ये भी कर सकते हैं कि थोड़ा से क्वांटिटी, थोड़ा सा अमाउंट ऑफ वाटर अगर आप इसमें पानी इसमें ऐड कर दें तो जब हीट अप होगा टेम्परेचर चैम्बर के अंदर तो वो पानी से भाप बन जाएगी, स्टीम बन जाएगी, जो कि आपके लोड को डिकंटामिनेट करने में मददगार साबित होगी। इसके अलावा बैग्स को अगर आप रबर बैंड के साथ क्लोज करते हैं हल्का सा, तो रबर बैंड भी लूज हो जाता है हाई टेम्परेचर में और फिर वो स्टीम को अलाउ करेगा इसके अंदर पेनिट्रेट करने के लिए। इसके अलावा अगर आप SARS-CoV-2 को देखें तो ये खासा सेंसिटिव वायरस है जो कि 70 डिग्रीज पर 5 मिनट की ट्रीटमेंट से भी इसको डीएक्टिवेट किया जा सकता है। और इसके लिए आम ऑटोक्लेव की जो नॉर्मल सेटिंग है 121 डिग्री सेंटीग्रेड पर 15 मिनट्स के लिए, वो भी इसको इनएक्टिवेट करने के लिए काफ़ी हैं, लेकिन फिर भी एहतियात ज़रूरी है। और हाई वायरल लोड वाले वेस्ट के साथ स्पेशली आपको बहुत ज़्यादा ख्याल और मुहतात रहने की ज़रूरत है। और आपको ये चेक रखना है इस सूरत में कि क्या आपका ऑटोक्लेव का पूरा प्रोसेस, उसका हर स्टेप ठीक तरीके से परफॉर्म हो रहा है या नहीं हो रहा। अब आपको ये मालूम होना चाहिए कि आपके पास किस किस्म का ऑटोक्लेव है और वो किस तरह से काम करता है। आपको ये भी मालूम होना चाहिए कि वेस्ट बैग प्रॉपर यूज़ करें और प्रॉपरली वो वाला बैग यूज़ करें जो कि स्टीम की पेनिट्रेशन को अलाउ करता है। और इसके अलावा आप वक्तन फवक्तन अपने ऑटोक्लेव की एफिकेसी को भी चेक करते रहें कि उसकी फंक्शनिंग में कोई इफेक्ट तो नहीं ऐसा हुआ है कि खराब अगर हो गया हो तो उसको ठीक करवाना और उसकी मेंटेनेंस बहुत ज़्यादा ज़रूरी है। Over to you, Philip.
Thank you, Afsa. Yes. I saw one question that was just asked now is, can we ask the supplier of the bags if what type of bags it is? I would say that yeah, I think you should, but I'm not sure that we'll be able to answer because they might not be themselves aware of the difference. And so the best way to do is to ask them for the technical data sheet of those bags. So the specification should tell first the materials of the bags, but they are most of the time the same type of plastic, but also the resistance and also what are their specifications. And in that case, you would know what type of bag you have. I'm not sure that the vendor, the supplier himself could answer that question in many cases. So you will need to ask for the documentation and discover by yourself, but that's something you can ask to a supplier. So now that chapter on validation, and I think that this will be a new book for many of you. Actually, validation is different from control, for instance. Validation is a documented verification process that provides evidence, that provides proof that a piece of equipment or a process performs as specified or exposed. So actually, in validating something, we check that the final result that we want is achieved, okay? So it's really, in the case of an autoclave, for instance, it aims at demonstrating that the autoclave performs as it is expected, but that's not that it reaches temperature and so on. It means that the waste or the material that we put inside of the autoclave is really sterilized or decontaminated. One condition for the validation to be suitable is that it needs to be done in conditions that are as representative, as close as possible as the actual condition of use. And that is about the waste, the cycle that you use, the parameters that you use, the type and volumes of loads, the packing materials, and so on. So everything should be in conditions that are as close as possible to reality. And then you do the testing to see if you have the expected result. And I say that it was different, validation was different from controls. Controls, they just aim to check that some specific condition have been reached during the treatment. And for instance, we can control that the temperature has been reached, the pressure has been reached, that there is some killing inside of the chamber and so on. But for instance, if you use even bioindicators in the chamber during the treatment, that indicates that the temperature was adequate in the chamber to inactivate the organism, but it doesn't say anything about the situation inside the waste bags. Okay, so it's different from checking a few points and having a validation of the process, telling you that the process is efficient and that at the end you have the expected result. There are a number of control means that can be used or are suitable on autoclaves. The first is the pressure and temperature probes that are most in general built in the autoclave. It's part of the equipment. But still, don't forget that these need to be calibrated. So during the maintenance program, you need to check if they indicate the right pressure, the right temperature. Otherwise, you have deviations and you will not operate as it is supposed to operate. Then in a number of autoclaves, and at least in the gravity displacement and pre-vacuum cycle autoclave, in that case, you have a cycle monitoring. So you have registration of the main parameters, and sometimes you have a sheet that with all the parameters that you can print at the end of the cycle. And then you have chemical indicators or indicator strips. They are poorly sensitive. Actually, mostly it shows that there is a contact with steam, which is already good, or they react to a temperature for about 110 degrees, for instance, but it's not extremely precise. So the main utility of that is to indicate that treatment has taken place. So if you have, for instance, flasks that have to be treated and flasks that you need to distinguish them from the ones that have been treated. And in that case, you can use that kind of indicator strips. And then there are, finally, there are biological indicators or BIs. The worst case BIs that are used for heat treatment and therefore for autoclaving as spores of a bacterium which is called Geobacillus stereothermophilus. So if we succeed in inactivating those spores at the right concentration and so on, in that case, that means that we will really kill everything because those are the most resistant. And so in that case, it indicates that the sterilization conditions have been reached, but at the place where the BIs are located. And most of the time, if we use BIs, we put them in routine operations, for instance, we will put the BIs somewhere in the chamber, but not in the middle of the waste bag. Why we don't do that? Just because the waste bags, they contain infectious material, so it would be a risk to put them there. And also because at the end, you need to recover them from the center of bag. If it's not well inactivated, people might be exposed. So what I will present you now is the best practice with respect to autoclave validation. And actually, it's what we call the qualification approach, and there are 3 successive phases in that approach. The first one is installation qualification, IQ. The question there is the autoclave installed properly? It's a complex instrument, a complex device, and it needs to be installed properly. I will explain a little bit more about the tests that need to be done. The second step is operational qualification, or OQ, and there the question is, does the autoclave work correctly? The third and last step is performance qualification, or PQ, and that's actually the true validation. And there, the question is, does the autoclave perform as expected? does it give the result that we are expecting? It's very important that those 3 phases are done one after the other. The reason for that is that we first need to be installed to work properly, and then before we check the performance, we should better be sure that it works properly. The main reason for doing those 3 steps in one after the other is that if you start the true validation without doing the 2 first steps, in that case, if you have bad results, if you have failed results, in that case, you don't know the reason. You don't have any idea. Is it because there is something that is lacking at the installation? Is it because there is something that is not functioning? So you don't have any ways to know that. If you are sure that it's installed and it works properly, in that case, if you have a failed result, in that case, you can focus on really the type of load, the type of things you put inside, and so on. So installation qualification, IQ, these are an example of the main check that you need to do, the main controls that you need to do. First, that the autoclave is at the right place, connected correctly, that the right programs are installed. Connection is about electricity, but also steam. And if there is a drain, also connection to the drain system. You need also to check that all the probes are there and that they are installed correctly, that the door, the joint of the door is correct, that is not damaged, and that the filters are in place, and also that the physical valve are in place. So this is mostly in checking a number of things in a visual way. Very importantly, this has to be done on a still autoclave. You are not putting the autoclave in operation. It's just looking at the autoclave. That needs to be done at installation, and then in a simplified way as part of the annual maintenance. And it should be done by some technical person, not by laboratory people, for instance, a technical person, but under the supervision of the laboratory people. Operational qualification, so to check if it works properly. In this case, it's done on an autoclave that works, but which is empty. There is nothing inside of the chamber. So we make it turn without any load. And in that case, we start with some basic tests, like is the door, to check if the door is closing properly, if it opens properly at the end of the site, if the emergency stop, if there is one, works. We also do the testing and calibration of the probes. It's not just looking if they are there, it's really testing them. We do some leak tests. Actually, we do that in using vacuum or positive pressure to be sure that it's not only there are not only visible problems, but that there is no leak, even a very small leak. We do also some filter testing and sterilization testing, and we test the different cycles to see if the right temperature are reached. The last thing we do is temperature mapping. That means we study the heat distribution within the chamber to be sure that there are no cold spots. And that is done with some temperature probes that we put in the chamber. So all this is technical, and it also has to be done by a technical person, again, under the supervision of the laboratory people. The true validation or performance qualification, in that case, we will really test waste bags in the case of waste, for instance. We will not use waste bags that are with contaminated materials. We will make kind of mock-up loads. So we'll use, for instance, bags, but with a number of items that are in the labs which are not contaminated. And then we'll test the different protocols with that. Usually we consider that validation is positive. When we have 3 cycles, 3 runs with the same type of load, and that all of them are successful, okay? So this has to be done after IQ and OQ. So at installation, but then after maintenance, for instance, but in this case in a simplified way. And in that case, you need to have the protocols for the cycles and the mock-up loads done by the people from the lab, but without any infectious materials. and you need the support for the technical part. But that's something that the user can manage. So there are major benefits in doing a validation like this. The main one, the general one, is to know if what you are doing is really efficient. And that's the main question. We should not use an equipment and don't know the resistance of, the result of what we are doing. So if the validation results are positive, in that case, you are sure that the biological wastes are actually decontaminated. You can show evidence of that to authorities, for instance, and you are also able to declassify the waste are non-hazardous. That means that it can be treated after that as domestic or non-hazardous industrial waste. That means that you don't need to take any additional precaution with the waste. It is safe, so waste handlers are protected, and you don't necessarily have to use a final destruction treatment like incineration. Another advantage is that if you do that, for instance, once at installation or once a year, then for all the cycles that you will repeat after that, so during the whole year, you will only rely on the physical parameters, so looking at the pressure and the temperature. And if you use the same type of loads, the same type of bags and so on during that time, you are sure that the result will be the same. And thus, this avoids the routine use of bioindicators, which are quite expensive, especially in a country like Pakistan. So there is some benefits, huge benefits in doing exactly the result of your treatment, and also in reducing the routine use of bioindicators. Then what if the results are negative? And that happens, and that will happen if you do it on some basic autoclaves. Then at least you know it, and so you should try to modify the parameters to make the decontamination more effective, and we'll see immediately what can be done there. But even if you don't have any possibility to change the parameters, in that case, at least you are aware that the waste may still be infectious. That means that you can take appropriate measures to guarantee, for instance, that the waste handler will be protected. So you can recommend or force them to have appropriate PPE. You also know that during transport and so on, you need to take precautions, and that ideally those wastes should be destroyed at the end. So how to improve the decontamination efficacy? There are three possible paths of actions that can be done separately or combined. The first way to do is to increase temperature. So if it doesn't work properly at 121 degree, you can try at 125 degree. That's not possible on all autoclaves. A second way to do would be to increase the treatment time. So instead of using 15 minutes, you could use 20 minutes or 25 minutes or half an hour. And that should be possible on all autoclaves. So this second possibility should always be possible. And then the third way is to modify the standard loads and packaging. So to modify your procedures actually. So you can decide to have more simple or smaller loads. That's one possibility. Or increase the steam contact using better bags or using some tricks to allow the steam in, like leaving the bags open, adding some water, or having a rubber that closes the bags and loosens when needed. So there are possibilities there. And then if in doing that you still don't have good results, in that case, at least you know that your waste is not properly decontaminated and that you should be careful with the waste after treatment. So Afsa, could you summarize this part also, please?
Sure, thank you, Philip.
Welcome.
अगला टॉपिक जो समराइज करने के लिए वो है ऑटोक्लेव ट्रीटमेंट की वैलिडेशन। वैलिडेशन का मतलब है कि डॉक्यूमेंटेड तरीके से ये साबित किया जाए कि आपका इक्विपमेंट जो है वो तवक्कुआत के मुताबिक काम कर रहा है। ऑटोक्लेव की वैलिडेशन का मतलब ये है कि हमारी ज़रूरत के मुताबिक क्या ये ऑटोक्लेव नताइज दे रहा है या नहीं, यानी वेस्ट को हस्बे तवक्को डिकंटामिनेट कर रहा है या नहीं। वैलिडेशन आप असल कंडीशंस के नज़दीक तरीन कंडीशंस में करते हैं, जिसमें कि आप एक्चुअल टेम्परेचर, प्रेशर, लोड, बैग्स वगैरह वही इस्तेमाल करते हैं जो कि आपने हकीकतन इस्तेमाल करना होता है। दूसरी चीज़ होती है कंट्रोल्स। कंट्रोल्स का मकसद ये चेक करना होता है कि क्या मतलूबा टेम्परेचर, प्रेशर और मतलूबा कंडीशंस क्या पूरी हुई थी या नहीं एक ऑटोक्लेव के प्रोसेस के दौरान। अगर ऐसा नहीं हो रहा और वो कंडीशंस नहीं मीट हो रही तो इसका मतलब है कि आपका डिकंटामिनेशन ठीक तरीके से प्रोसेस नहीं कंप्लीट हुआ। और इसके लिए आपको प्रोब्स की सेटिंग ठीक होनी चाहिए। किस तरीके से आप ऑटोक्लेव्स को कंट्रोल करेंगे वो ये कि आपकी प्रोब्स की सेटिंग ठीक होनी चाहिए, और आप केमिकल या बायोलॉजिकल इंडिकेटर्स भी इसके लिए ठीक कर सकते हैं, यूज़ कर सकते हैं, जो कि केमिकल इंडिकेटर्स इतने ज़्यादा सेंसिटिव नहीं होते और वो सिंपल ये चीज़ आपको बताते हैं कि क्या एक प्रोसेस हुआ है या नहीं, यानी स्टीम प्रोड्यूस हुई है या नहीं। फॉर एग्जांपल वो ये नहीं बताते कि क्या वाकई डिकंटामिनेशन हुई है या नहीं। दूसरी चीज़ है बायोलॉजिकल इंडिकेटर्स। ये वर्स्ट केस में हम इस्तेमाल करते हैं हम लोग जियोबैसिलस स्टेरोथर्मोफिलस स्पोर्स को, जो कि हाई टेम्परेचर रेजिस्टेंट है, और जब तक वो टेम्परेचर अचीव नहीं होगा तब तक आपको ये इंडिकेट करेगा कि क्या वो टेम्परेचर रिक्वायर्ड अचीव हुआ था या नहीं ड्यूरिंग द प्रोसेस ऑफ ऑटोक्लेव। अब ऑटोक्लेव को वैलिडेट करने के लिए बहुत सारी अप्रोचेस हो सकती हैं, जो कि बेस्ट अप्रोच है ऑटोक्लेव इसकी 3 फेज अप्रोच, जिसमें कि क्वालिफिकेशन अप्रोच जिसको कहते हैं। इसके 3 स्टेप्स आप कह लें। पहला स्टेप इंस्टॉलेशन क्वालिफिकेशन, दूसरा ऑपरेशनल क्वालिफिकेशन और तीसरा है परफॉर्मेंस क्वालिफिकेशन। और अगर आप एक स्टेप की क्वालिफिकेशन कंप्लीट कर लेते हैं तो फिर आप नेक्स्ट स्टेप की तरफ मूव करते हैं। इंस्टॉलेशन क्वालिफिकेशन में बेसिकली आपने ये चेक करना है कि क्या ऑटोक्लेव ठीक तरीके से इंस्टॉल हुआ है या नहीं, स्टीम के और इलेक्ट्रिसिटी यानी बिजली के कनेक्शंस वगैरह ठीक है या नहीं, टेम्परेचर और प्रेशर के प्रोब्स जो उसमें इंस्टॉल हुए हैं क्या वो ठीक है या नहीं, इसका ऑटोक्लेव का दरवाज़ा एयर टाइट है या नहीं, कहीं से लीक वगैरह, उसके जॉइंट्स वगैरह तो ठीक है, कुछ डैमेज तो नहीं है, उसकी फिजिकल बॉडी पे कोई डैमेज तो नहीं है, उसके फिल्टर और वॉल्व वगैरह वो क्या ठीक है या नहीं। ये इंस्टॉलेशन क्वालिफिकेशन जो है ऑटोक्लेव को इंस्टॉल करने के वक्त की जाती है और इसको बंद ऑटोक्लेव के साथ किया जाता है, फिजिकली उसको सिर्फ देख के मॉनिटर किया जाता है। दूसरी है ऑपरेशनल क्वालिफिकेशन, जिसमें आपने सालाना मेंटेनेंस के तौर पे भी आप ये क्वालिफिकेशन चेक कर सकते हैं, और दूसरा आप इंस्टॉलेशन के वक्त भी करते हैं। इसमें ये देखा जाता है कि बगैर किसी लोड के क्या ऑटोक्लेव ठीक तरीके से काम कर रहा है, यानी कोई लीक वगैरह तो नहीं है, टेम्परेचर और प्रेशर वगैरह के साइकिल्स और फिल्टर वगैरह क्या ये सब चीज़ें ठीक काम कर रही हैं या नहीं कर रही, और इसको विदाउट एनी लोड बगैर किसी चीज़ के उसके अंदर डाले, आपने सिर्फ उसको चेक करना है कि क्या वो ऑन होता है और ठीक तरीके से काम करता है या नहीं आपका ऑटोक्लेव। तीसरा परफॉर्मेंस क्वालिफिकेशन जो है, तीसरा स्टेप है वो परफॉर्मेंस क्वालिफिकेशन का, जो कि असल वैलिडेशन है, और इसमें ये चेक किया जाता है कि क्या ये मॉकअप लोड्स को अच्छी तरीके से डिकंटामिनेट कर रहा है या नहीं। मॉकअप लोड्स से नहीं, आर्टिफिशियली लेबोरेटरी में बनाया गया लोड्स जो कि मिमिक कर रहा हो असल लोड के, जो कि वेस्ट आपका प्रोड्यूस होता है लैब में उसमें। इसमें बायोलॉजिकल इंडिकेटर को भी इसमें साथ यूज किया जा सकता है, और ये इंस्टॉलेशन क्वालिफिकेशन और परफॉर्मेंस क्वालिफिकेशन से क्लियर होने के बाद आप इसकी ये परफॉर्मेंस क्वालिफिकेशन करते हैं, और आर्टिफिशियल नॉन इन्फेक्शियस लोड के साथ उसको लैब में प्रिपेयर करके और फिर आप उसको यूज करते हैं बायोलॉजिकल इंडिकेटर के साथ कि क्या ये वाकई डिकंटामिनेशन का प्रोसेस ठीक तरीके से, इफेक्टिव तरीके से वैलिडली हो गया या नहीं हुआ। अब इस अप्रोच के डिफरेंट फवायद हैं, वो ये कि मुस्बत नतीजे आने की सूरत में आपको इत्मीनान होता है कि डिकंटामिनेशन ठीक हुई है, और आप अपने वेस्ट को नॉन हैजर्डस वेस्ट और महफूज तरीके के वेस्ट के साथ आप उसको ट्रीट कर सकते हैं। आपको इसके लिए परेशान फिक्रमंद होने की ज़रूरत नहीं है कि उसकी फाइनल ट्रीटमेंट भी की जाए, और इस तरह से आप अवॉइड कर सकते हैं बायोलॉजिकल इंडिकेटर्स के हर वक्त के रूटीन यूज़ को आप अवॉइड कर सकते हैं। और अगर दूसरी सूरत में अगर नेगेटिव रिजल्ट्स आते हैं तो आप इस सूरत में आप ऑटोक्लेव के बाद भी आप वेस्ट को एहतियात के साथ मजीद आप हैंडल करेंगे और अपने ऑटोक्लेव के प्रोसीजर को आप बेहतर बनाने की कोशिश करेंगे। अब डिकंटामिनेशन एफिकेसी को बेहतर बनाने के लिए आप क्या क्या कर सकते हैं, इसके 3 तरीके हैं। वो ये कि एक तो आप ऑटोक्लेव के टेम्परेचर को बढ़ा सकते हैं, दूसरा ट्रीटमेंट के टाइम को बढ़ा सकते हैं, जैसे 20 मिनट के बजाय आप 25 मिनट का ट्रीटमेंट दे दें, और तीसरा ये कि छोटे छोटे सादे से बैग्स बनाएं ताकि स्टीम करामत तरीके से अपना काम परफॉर्म कर सके और सिंपल लोड उसे बनाए बजाय इसके कि एक ही बहुत बड़ा सा बैग और कॉम्प्लेक्स बनाने के आप छोटे छोटे से लोड्स बनाकर उसको रिपीटेडली ऑटोक्लेव में रन कर लें। तो इस तरह से आप लोग अपने वेस्ट को अच्छे तरीके से डिकंटामिनेट कर सकते हैं। थैंक यू सो मच। इस पार्ट में अगर कोई क्वेश्चन हैं तो वो प्लीज आप लोग पूछ सकते हैं। Over to you, Philip.
Yeah, thank you very much.
Thank you.
Okay, actually there are 3 questions and I will try to answer briefly. The first, the last question actually is what can we use for mock-up load? Actually, if you use waste bags, for instance, the mock-up load should be the same type of waste bag, and you put inside of a waste bag a number of things that you have in your lab, like you produce real waste. The only thing is that they should not be contaminated. There should be nothing infectious. So if, for instance, in the waste bag you have some gloves, some tips of pipettes, some absorbing materials, a few small bottles, and so on. You put everything that in the bag. In some way, it's waste, but not infectious. And in doing that, in defining exactly what is that becomes also the basis for the procedure after that. And you will always use the same kind of load. That's the way to do. So you do it as close as possible as the real situation, but not infectious. The second question is about autoclaving tapes. And so autoclaving tapes, I'm pretty sure that they are chemical indicators. So the question is does it mean that autoclaving was successful? Actually, it means that steam and a more or less correct temperatures was reached where the tape was placed. So that means in the chamber, but it doesn't say anything about the inactivation inside the bag. So it is an indication, but it doesn't say that everything is killed inside the bag. Okay. And then the last question I have, and it was asked before I explained the whole thing about validation, so perhaps it's clear now. The question was, how do we keep check on autoclaves daily efficiency so as to make sure it is not compromised in any case? Actually, if you don't have validation, in that case, you need to check a number of things. You need to check the pressure. That's quite automatic, but you need to check that you have the right temperature inside. So you need to use bioindicators. Most of the time, people use, for instance, bioindicators every week or for every 3 cycles or something like that, which cost a lot of money. But those bioindicators, those indicators are outside of the waste bag, so it still doesn't say anything about the inside. If you proceed correctly with the validation using representative waste load, mock-up loads, and if you have those 3 successive runs showing that in all the cases with small difference in the loads and so on, you still always inactivate your waste, in that case, after that, you don't have to do any check. You just rely on the temperature and pressure. It's physical, so it will repeat the same way all the time. It's the only fail that could happen is if you modify the loads, and that's something you should not do, or if there is a problem with the autoclave and the pressure and temperature fail. But in that case, you will also notice it because of the probes and the alarms. So that's the very big difference between validation and checking. You will reduce the need to check if you have a good validation. So I think I answered the questions, except that there is a new one that arrived there. It's again about the color tape. Actually, if the color changed, it means that some high temperature has been reached, but it's not sensitive. And of course, it will depend on where you put it. So it's some indication, but it's not the best one. So I see that it's exactly the time to finish. Thank you for your questions. I hope you found it interesting and you will be able to improve things in your facilities. The last session will be answering all the questions that were asked during the 3 first sessions, and that will be done next Tuesday, August 25, at the same time. If in the meantime you have some additional questions because you thought about some of the presentation and so on, don't hesitate to send them to the PEPSA office. Okay, thank you, Marshall. Thank you, Afsa, for your very great help, and thank you everybody for your participation. Thank you, and bye-bye.
You're most welcome, Philippe. Thank you so much.
Thank you, everyone. This session has ended, and inshallah, we will have our question and answer session on 25th of August. Thank you, everyone.
Thank you. Bye-bye.